Okay, folks, here are some further examples from section 5.1 on composition of functions, and these will be similar to some of the homework you need to do in this first set of work on 5.1. Again, the definition, f composed with g, is f of g of x. And now let's talk about how to find the domain of a composition in an efficient way. Actually, there's some logic to this. When an x goes into f composed with g of x, first it hits the g function, remember, like in the machine where you hit g and then it goes to f. So it hits g first. So to be in the domain of f composed with g, it's going to have to be a value of the input that makes sense in g. So right off the bat, you have to exclude any values of x that are not in the domain of g of x, or else they're not going to work in the composition. But then, after the input goes into g of x, g processes the input, and the result, the g of x, has to go through f. So g of x, the output from g, has to be in the domain of f for this to work. So first you exclude the values of x that are not in the domain of g, and then, here's the kind of tricky one to say, you exclude the values of x for which g of x is not in the domain of f of x. Interestingly enough, you don't necessarily need a number to be in the domain of f in order to be in the domain of f composed with g. You just need it to be in the domain of g, and you also have to have it not be a number for which g of x is not in the domain of f. It's complicated to say. Not so bad to do in practice. So starting with the same functions I was using in my example before, x squared minus 1 for f of x and g of x equals 1 over x. Let's find the domain for f composed with g of x, and then find a domain for g composed with f of x using this approach. So first, find a domain of f composed with g of x. First, I have to exclude any values that are not in the domain of g. So here's g of x, familiar function. You can picture the graph, I hope, of 1 over x. And the domain is all real numbers except 0, right? The graph actually has a vertical asymptote at x equals 0, and if you try to plug in 0, you get 1 divided by 0 undefined. So right off the bat, I'd have to exclude 0 because 0 is not in the domain of g of x. Okay? Part B says I have to exclude any values of x for which g of x is not in the domain of f of x. So let's look at f of x and see if we've got any domain problems here. Actually, f of x is a quadratic polynomial, a parabola. And like all polynomials, it's got all real numbers for the domain. You can square any number and subtract 1. So I've got no problems with f, and there are going to be no places where g of x is not in the domain of f of x. So no sweat there. And it looks like my domain is just all real numbers except 0, huh? Okay, let's look at the composition the other way. It won't surprise you to know that this will behave differently. So let's see, find domain of g composed with f of x. So now my first step is exclude values of, actually f, exclude values of the inside function. We'll call that, I'll talk about that a little bit later. But this is g of f of x. So when an input goes into g composed with f, the first function it encounters is f. And so I have to exclude anything that's not in the domain of f of x. Let's see, f is a polynomial, no exclusions, right? All real numbers is the domain of f, so I don't get anything out of part A. Part B says exclude values of x for which g of x is not in the domain of f of x. Okay, well, I'm flip-flopping g and f here. I have to exclude any values of x for which f of x is not in the domain of g of x. Okay, so how do I get at that? I have to exclude any value for which f of x is not in the domain of g of x. g of x does have an excluded value, right? X can't be equal to 0. So I can't have my output from f be equal to 0. So in part B, I'm going to do a little algebra. I want to actually solve f of x equal 0, because I'm looking for places where the output from f of x is the excluded value for g of x. I can't have f of x be 0 or g of f of x is going to be 1 over 0. So I'll solve this. F of x is x squared minus 1. So I'm looking for values of x for which x squared minus 1 is 0. Those will be the problems that I need to exclude. So let's see, I guess I can do this by a square root method. If I isolate x squared equals 1, then x is, careful now, 1 of the square roots of 1. Could be either positive or negative 1. So the domain of the composition here, can you see this coming? All real numbers except, well, anything that was not in the domain of f, but I didn't lose anything there, and anything for which f of x, for which x squared minus 1 was equal to 0, because 0 is not in the domain of g. So everything except positive and negative 1. One other type of problem that's in the homework that I'd like to tell you about. Let's see. Let me wipe this stuff out quickly.